Hey guys, welcome back to the Beginner's Guide to Restoring Early Magnetically Deflected Black and White Televisions. In this installment, I'm going to change things up a little bit. A little less theory and more practical hands-on stuff on top of the chassis. I want to talk about the stuff on and around the CRT. The focus coil, the ion trap magnet, the deflection yoke. What they are, how they work, how you set them up. I see a lot of confusion, some misinformation about this stuff floating around out there. Adjusting them is very important to the correct operation of your set. So let's get to it. When I refer to these sets as being electromagnetic or electromagnetically deflected, this is the stuff I'm talking about. These are the magnets that put the magnet in electromagnetically deflected TVs. Ion trap magnet, electromagnet focus magnet, and electromagnetic yoke coils. All three of them are critical. They interact with each other to some degree, and there are some slight differences in how they're set up, but we can generalize for the most part how they work. So let's get to it. Let's start with the one furthest back. I see this referred to the ion as an ion trap all the time. No, this is the ion trap magnet. The ion trap is really more of a concept than an actual physical thing. It comprises the way the gun is constructed inside the glass here in conjunction with this magnet. This whole assembly is the ion trap. What is that? Why do you need it? I'll get out the whiteboard in a moment, but I'll just talk you through it right now. So we have a vacuum inside this glass here. This electron gun here, well, it's a gun that creates electrons. And we have high voltage up here that accelerates. And what's a particle accelerator, essentially? Ideally, it's a 100% perfect vacuum, and all we have are electrons getting accelerated, getting deflected. When the electrons hit the phosphor coating, it emits light. Nothing's ever perfect. You cannot get 100% perfect vacuum, not here on Earth. There are going to be some stray molecules of air. There's a getter in here. Getter is reactive metal. I think it's right about here. That helps to scrub out some of the residual air molecules in there, but there will inevitably be some. Where do they come from? Well, remember, we have glass, but there's also this metal structure in here. And then there's this phosphor coating itself, and there's an internal graphite type coating on the inside of the glass. They spray those on, they coat those on. This metal is welded and has various components to it. Those are going to have some air molecules trapped in the metal lattice, trapped in the phosphor. They start evacuating this and the air gets sucked out of this material, but there's going to be a few stubborn atoms that are clinging on that will later on get released. It's not so much air leaking through the glass and getting inside as little bits of air that they just stubbornly clung on to the surfaces when they were evacuating it. All right, so why is that a problem? Well, they also get accelerated, and they also shoot towards the front of the CRT, and they also hit the phosphor. But they damage the phosphor. They're much heavier, much larger than this. Electrons have essentially no mass. They hit it and they release some energy and you get light. Something like an oxygen atom smashes into that phosphor and actually damages the phosphor. And then some more material may get ejected, and the cycle repeats. The atoms keep getting accelerated, hit the front, and then circle back around. Eventually, you get a spot. Really early picture tubes, pre-war, they didn't account for that. They just let the phosphor turn brown. It was such a novelty to have a TV at all. I think that was acceptable. I think they knew it was a problem early on, but I don't think there was enough of a effort to correct it. I don't know. Very quickly right after World War II, they had solutions readily at hand, but there were a few really early sets, or early Stromberg Carlson. I have one that they used the CRT. I think it was a 12QP4. Dumont did too, 12JP4. They didn't have ion traps, and they sold these commercially in 1947-ish. And after a couple of years of watching them, you gradually got a brown spot about yay big in the middle of the screen. So why does that happen? The ions, the atoms, the air molecules, nitrogen, oxygen, whatever it may be, they're more massive and they don't get deflected as much by the deflection coils here. So you got your electrons going left, right, up, down, painting over the whole screen. These don't deflect those as much. They have more mass, they're getting accelerated, they are less deflected by this, so they tend to bunch up in the middle. They just shoot down and kind of hit in a small spot in the middle. And it turns brown over time. That's why you need this. This in and of itself, this magnet out here, does not correct the problem. Again, a magnet does not deflect those heavy ions that much. So what do they do to solve the problem? The electron gun inside here is not pointing to the front of the CRT. It's pointing out the side of the neck. The electrons and the ions are being accelerated like down here. They hit on the neck somewhere around in here. The magnet is there to bend the electrons back up so they do go forward. So everything is accelerated away from the face of the CRT. These magnets, which are fairly weak, but they're just strong enough to bend the electrons up so they go straight. It's not enough to move the ion, deflect the ions back up so they hit the screen. So we just end up getting electrons. The ions just hit the side of the neck. Sometimes they hit some gun structures or the glass and it causes it to glow a little bit. You may see a blue glow inside there on some of the elements inside. It's not necessarily a bad thing. It's just stray ions getting accelerated and hitting other surfaces inside. Adjusting this is critical because if you don't adjust it right, the electrons don't go straight. They continue on and hit stuff inside the neck. In the worst case scenario, there's a lot of discussion online about sets that folks had seen that had ion trap assemblies but still had ion burn. And there was a lot of speculation about how is that possible until finally somebody found an article that explained what can happen. If this magnet is misadjusted, the electron beam, instead of going straight towards the screen, hits other metal elements inside here and vaporizes them, like a little laser beam. And the metal gets vaporized, and it gets accelerated and deposited on the front of the screen. It doesn't quite look like a phosphor burn, but it definitely makes a shadow on the phosphor. That is from a misadjusted ion trap, vaporizing material that gets deposited where it shouldn't be. And I'd seen the warning for years about a misadjusted ion trap magnet can cause damage. And I wondered for a long time, what are you talking about? What kind of damage? Yeah, you don't get a good image on the screen, but what's possibly getting damaged? I never realized it could actually, that electron beam is so intense, it can vaporize material that then gets accelerated and smashes into the phosphor and damages it. Don't want to scare you or worry you, though. You have to have it misadjusted for a long time for that to happen. More crucially, you want to adjust it correctly so you get a bright image. There are two types of ion trap magnet. This is the double pole, and also single pole. There are two ways to do the bending of or sending the beam off to the side. Some physically have a bent gun. It's very obvious when you look inside there. Instead of being a metal tube that runs down the center, there's a very noticeable bend to it. And it's obvious, kind of obvious when you see it. And that's what the double ones typically are. There's a very distinct angle to the gun where it's pointing off in one direction, and then you adjust this so that it bends things back. The single one, the gun is a straight tube, but there's a slit. There's like a 45-degree angle slit cut into it. Now this kind of has that too, but it does use a double pole. You really need to look. Ideally, your set still has this, and it came with it. Otherwise, look at the data sheet. Your 10 BP4, 12 LP4 like this is, use a double pole. There is a remote possibility if it's been rebuilt, they rebuilt it with a gun that only requires a single trap. So again, ideally, 99% of the sets I come across still have this with the set, so it's not really an issue. Also, really, really early sets, this is kind of cool, like the RCA 630TS first generation, used electromagnets for these. And there's actually an adjustment. You vary the strength of the magnetic field to help really fine-tune it. Otherwise, these are permanent magnets. I guess they can go weak over time. And I've seen aftermarket replacements where you can adjust the Gauss, the magnetic strength, the knob. They tell you in the data sheets it should be a certain number of Gauss or milligauss, microgauss or something like that. Rarely do you have to deal with anything to that extent. Most of the time it's going to come with the set. The important thing is where you position it. I've seen so many folks. They recap their set, they power it up, they got high voltage, and there's no illumination on the screen whatsoever. It's because this is misadjusted. If it's misadjusted, it's just a slight, if I turn this 10, 15 degrees or slide it forward or back, I can have zero illumination on the screen. It really is an important adjustment. How do you do it? Well, if you look at the instructions that typically tell you to turn the brightness down a bit, loosen these up. These are some screw clamps on here. And now I can move it around. And you want to rotate it. Could potentially go all the way around. You don't know where that sweet spot is if somebody's messed with this. And to go forward and back. Usually, pretty quickly, if you just do this fast and look at your screen, put a mirror in front of the set if you need to. As soon as you see some illumination, stop, and then slow down and work your way into zeroing in. I'll show you this in a bit. But the important thing is to just get something on the screen to get in the general vicinity, and then it's fairly easy to fine-tune it. Now, I mentioned about the stuff interacting. Well, right next to it, this is the focus coil. Later sets have electrostatic focus. These early sets are magnetic focus. Meaning we've got an electron gun here, right? And it's spewing out electrons. Before you get to this, the beam is not, it may be this wide, maybe 1/8 of an inch beam of electrons. We want to get that as sharp as possible so we can draw nice sharp lines on the face of the CRT. We need to constrict that. We need to focus it. Exactly analogous to focusing light. That's what this does. It squeezes the electron beam into a tight beam. Less than 1 millimeter, I would say, across. This is a magnet. A fairly hefty one. There are a lot. It's sort of like a field coil, rather, in a speaker. There are thousands of turns of wire in here. You got 2 wires going out. It's right next to this. So these two will interact with one another. In other words, you can get a nice sharp focus and you adjust this a little bit and it gets slightly out of focus. You got to adjust the focus. It can move the image a little bit. So it's another fun side effect of this. Not only does this focus and this do your ion trap, as you move this and fine tune it a little bit, it can shift the image around a little bit. You can also get some distortion in the corners. It's a pain. It's a pain. Or it can be. You just have to go slow, methodical. You can spend a lot of time on this stuff. Because the fun keeps coming. The fun keeps coming. Notice this is mounted on 4 screws. You can adjust these. They have springs on them. This moves in and out. So the general order of operation is you always have to adjust this so you get some illumination, get it so it's pretty decent. This, you typically have a variable rheostat somewhere that will adjust the current going through this, which will change the magnetic strength. That'll focus it. But it can be off-center. Sometimes it's tempting to just grab this and tweak it a little bit to center the image, but really you should always adjust this for maximum brightness and minimal distortion, but really just maximum brightness across the whole screen. These 4 screws, you adjust these to center and correct for geometry defects as best you can. Remember, these are early sets. Don't expect to get 100% perfect. Linearity, geometry, everything. But you can generally get pretty good. Now, some sets, this is fixed mount, or it can only move forward and back. It doesn't have these 4 adjustments. This is a cost-saving measure. And I totally understand why Admiral did it, and I don't have a problem with it. The early RCA or contemporary RCA designs that this is very, very similar to varied a small DC bias current through the deflection yoke to accomplish centering. So they actually have potentiometers for horizontal and vertical centering. They do that by letting a little trickle of current go through the deflection yokes, positive and negative, so you can move the image up, down, left, right. And this doesn't move. That really complicates the power supply. If you look at an RCA set from this era, they have both negative and positive voltage rails, and it's ugly. Yes, it's a very, very nice thing to have knobs to center the picture and some other nifty features the RCAs have, but boy, does it complicate things. They probably saved quite a bit of money by just using 4 springs and 4 screws and eliminating all those extra power supply components and potentiometers. So, you get this for your maximum brightness. Move this back and forth if you need to. Adjust your focus control so it's brightly focused. Then get out your flat-bladed screwdriver and tighten and loosen these to center the picture. Sometimes this is mounted on a gimbal, and you might have a handle that comes all the way back out the back of the set. And you can just move that control up, down, left, right, which shifts this around on pivot points. Just happen to have another set in the pipeline. It illustrates some of the things I've been talking about. Single ion trap magnet, and this has a gimbal assembly on the focus coil. I have this little handle here. You flip it down and you can crank on it and move the whole coil left to right and pull it and push it. So rather than having those 4 screws, you just manipulate this handle. Now there are other centering schemes that use magnets. Here's one that I expect some of you are quite familiar with if you've worked on TVs before, where they have 2 magnetic rings around the neck with ears sticking out, and you move these to center the picture. Same idea as having the 4 screws where you move it around. You're manipulating a magnetic field. Finally, we get to this guy, which is the actual deflection yoke. There's very typically a thumb screw up here, which you can loosen. You want to make sure that this is shoved up as tightly as possible, or if it is, well, you want to make sure it's resting right against the glass of the bell of the CRT. It's obscured by this. Now, this is as far as forward as it will go, but it's not touching this. You may need to move the CRT back, and it's mounting. You want to make sure that these are pressed as tightly together as possible so you get full deflection across the screen. The other reason you loosen this is so that you can tilt it left to right. That is how you level the picture. If you have a crooked image, in other words, the horizon line, it's not perfectly level, that's how you do it. You loosen this, go back and forth, make sure it's all the way up, adjust these, and there's 2 more down below to center the image. And if you need to, you can move all 4 of them in or out if you don't have enough range with your focus control to get a good focus. And you adjust this for maximum uniform brightness. Got all that? Good. Hey, maybe a good old Grob can help me out here. I won't have to draw diagrams. First, I want to mention there is another way to do the focus, which he illustrates a bit here, and I just happen to have one. It's a focalizer. What is a focalizer? It's a permanent magnet focus coil. So rather than having an electromagnet with adjustments, this is a uniform circular permanent magnet. And it has adjustments you can make here to actually do the focus adjustment between this guy. It does have a spring in here, and this adjust the magnetic field so it can focus things. You start seeing those more as you get into the 50s. So he's talking about all the same thing here with the ion trap magnet, deflection yoke, centering magnet. Just hoping he has a diagram showing how the ion trap works. At least we get this. So where he talks about the gun and how the focusing kind of squeezes it. So inside there we have a filament, we have a cathode, we have a modulating grid, and if it's an electrostatically focused set, it will have a special focusing element, otherwise it's magnetic. Good, it does have a nice diagram showing it. Alright, so here's our electron gun with our beam coming off. It shows the ion beam going off to the side, whereas the ion trap magnet is bending the electrons back up so they go out towards the front. So that's how that goes. Notice in this diagram, that electron gun, it's angled. It's angled downwards. And finally, there's a deflection yoke. There are 4 coils in there, 2 that move the beam up, down, and 2 that move it left, right. Now, there is another entirely different way to do all of this stuff, which is electrostatic deflection, which doesn't have any of this stuff. There's literally nothing on the neck of the CRT except maybe a shield, and all the action happens inside. We'll talk about that in an entirely separate series. I don't want to confuse things. Now, I will illustrate the effect of moving this around and these other things, but something else I want to do. If you recall, way back when I got this set, this strap that holds the CRT down is chewed up. Probably some critter was gnawing on that. I want to replace that. I have this stuff, which is used for running cables through. It doesn't have any give to it. I think it's exactly the same width. I think this will be a fine replacement. I imagine it's a nylon. So let's get out some tools and remove this strap and secure this down. Then I'll hook everything back up. We can play around with this stuff and see what effect it has. Alright, now let's see about this strap as usual. A bunch of 1/4" sheet metal screws. Different manufacturers did this different ways, but typically there is a band, sometimes metal, sometimes cloth. The metal ones will usually have some kind of padding underneath. Rubber, double-sided tape, something like that, because ideally you don't have metal against glass, but I've seen somewhere, yeah, it is just a flat piece of metal band right against the glass. This kind of fused a bit from age. But there we go. Nothing too complicated about this. Just a bracket on either side. We can use this as a guide to cut a new piece down to length. So right about there. I'll leave it a little bit longer. Now underneath these, there's typically a rubber pad or 2, so not just one big piece. In this case they have 2 pads on these adjustable brackets. It's a nice setup. This would accommodate different screen sizes, so if you had a 10-inch screen you could slide these closer together. These pads are actually in pretty good shape. They still have some give to them, so I'm going to leave them alone. There's also a piece of metal here with, this bit of rubber is kind of hardened, but there's a piece of metal here with 2 screws to keep this CRT from popping out forward. This has been here a very, very long time. This is, well, it appears it's been rebuilt, but since it was rebuilt, I don't think this, that was done a very long time ago is what I'm trying to say. Anyways, so Now, if these were crushed or bottomed out or degraded in some way, sometimes if these shrink down so much, the screen will drop and it won't line up right in the cabinet. Carefully, in this case, you could take these off. You might have to undo the stuff that we just talked about on the neck, that ion trap magnet and whatnot, and move this thing, remove it from the chassis entirely and replace those mounts. Or carefully lift it up a little bit and slide some new mounts under there. You don't want to lift this up too much, though, because you will snap the neck off. Because remember, we have all that stuff attached to it on the back, which doesn't really have much give to it. So you have to be very careful when you're manipulating this. This is thick glass. This is where all the weight is. And neck is much, much thinner glass and quite fragile. Anyways, these just go around, and as you tighten down the screws, it puts tension on it. Of course, when it's in the cabinet, I mean, really it's the weight of this holding. It's not going anywhere even with that strap off. But it's certainly a good idea to keep it in place. You definitely not want to tip this on its side with that strap off. Alright, so we'll do one side. And when we do the other side, that's what really going to tighten it down. There we go, nice and tight. That is really on there. Let's trim off a little bit of the excess. Get the other chassis up here, hook everything up, and let's play around with some of those adjustments on the back. Alright, so one of the issues with doing this is, how do you see what's on the screen while you're at the business end? These sets are pretty deep. If you're in the front, it's pretty hard to reach around to the back, and you don't want to get shocked by anything. So there are things like this. Invaluable service aid. What is it? It's a mirror. Of course, you don't have to get the actual vintage serviceman's device. You can use any mirror, but they come in really handy. And this actually isn't even glass. It's just stainless steel, which makes sense because you don't want to have this break when you're lugging it around. So, let's see, can I arrange this such that you guys can see what's on the screen while I muck around the back. So let me see what kind of camera magic I can work here. Alright, let's give this a try. So, first thing, let's do the ion trap magnet. So I'm going to loosen it up, and I'm going to intentionally move it. So, see, I just moved it a little bit. We have no image whatsoever. And subdue the lighting. I'm going to turn the brightness up a bit. And I'm going to start moving this around so I can kind of get something. Once again, really bright, so the brightness turn up all the way. Now I want to turn the brightness down so I can just barely see it. And now move it around until it's as bright as I can get it. So initially I turned the brightness up all the way because I wanted to quickly get in the ballpark of where I need to be. But I want to turn it down because I want to keep that beam current down to lessen any... in other words, I want to keep... When you have the brightness turned up all the way, you have the maximum electron emissions, and I want to reduce the chance of anything getting damaged by it being misaligned. So I want to quickly get in the ballpark, but once I do, I can turn the brightness way down. Kind of like with aligning a radio, whereas you peak those coils every time it gets really loud, you turn down your signal level. Similar idea with this. Now this isn't necessarily the best pattern because there's not much going on, so let's go to some bars. There's some stripes there. me, my dog is chewing on a vacuum tube box, because that's what he does. This can be finicky. You're trying to find the absolute best spot. Every time I think I have it, I move it a little bit and it disappears. Okay, now I want to center the image using those screws on the back. It needs to come towards me. It needs to go this way to, I guess it'd be your left, I think, towards this way. So, we have these screws mounted here. I'll pinch one in a little bit. See, if I tighten this one down, it's moving it the opposite way of what I want. Now, those are pretty tight, so I may, rather than tightening the one on this side, I may want to loosen that one. To do that, we need a bucket screwdriver. It's not going to move it a ton. So try tightening this too. Oh, am I going the wrong way? Oh, no. Oh, there we go. I was going the wrong way. I need to loosen it on this side and tighten it on this side. Oh, there's 4 of them. Okay, so that's not going right either. So actually I need to loosen up both of these to go left. Keep both of them loosened. Let's see what this bottom one does. If I tighten the bottom one, it goes to the upper left. So there's 4 of them. I shouldn't say that, so these 4, none of them go up, left, up, down, left, right. They all move it diagonally. So this bottom one goes kind of up and to the left a little bit. See, don't I go too far? Yeah, I want to go back the other way a little bit. So let's tighten this back down. Pretty good though. We're pretty close. Except for this corner down here. Now there's something I mentioned earlier about the ion trap. I'm going to move it a little bit. And notice it changes the brightness, but it also moves the image a little bit. And it kind of distorts it a little bit. That's the magnet thing about this stuff, is everything interacts with everything else. Or all these magnetics do. And now I'm going to loosen up that yoke thumb screw and rotate it a little bit. So that's how you do your leveling. So let's make sure that's up as far as it can go. I think that's pretty level. Some of these I would recommend you don't do until you've got this installed in the cabinet. Crazy as it may seem, the Earth's magnetic field has a subtle effect on this, especially early color sets. So you could have it in your workshop on your workbench and get the convergence when you have those 3 beams, the red, green, and blue perfectly aligned. You reinstall the cabinet, put it in your living room in a certain corner, now they're off. It's because literally you changed its orientation to the Earth's magnetic field. Black and white, not so much an effect. But be aware of this. If I had this chassis on its side while I was doing this and then put it back upright, this could shift subtly in its mounting. That would definitely have a very detrimental effect on it. So don't go crazy doing this until you've actually, well, for sure got it in the right position. In this case, the chassis down, like it's going to be in the cabinet. But even better yet, do it when it's in the cabinet. But some of these things can be hard to get at when it's in the cabinet. At least the ion trap you should be able to do up on the workbench. So this is pretty good, but I'm not liking how this corner kind of gets dim down there. But that's not it. See, that's what they call a shadow. It's not off screen. There's a dark spot there. That can happen when the electron beam is actually hitting the side of the gun. Let's see if I move the ion trap a little bit, it gets better. Actually, it gets way better there. So you want to adjust this for maximum brightness, but also so you're not getting a shadow. So it actually was centered. It's just electron beam was getting kind of cut off. Kind of right about there. Seems to be pretty darn good. And I hate to say it, but don't expect perfection. Obviously, get it as good as you can, but sometimes you just can't. I've heard tales of servicemen attaching external magnets, attaching them to the inside of the cabinet or somewhere around here to act as a little subtle adjustment that you can't make with the built-in stuff. But that's the general idea there. You adjust this guy for best brightness and no shadow. You adjust this or whatever mechanism it may have for centering, and you adjust the yoke so that it's horizontal, and you want to make sure it's all the way up against the CRT. I hope that all made some sense. Next time around, we're going to get back to talking about the sound, how the FM audio modulation works, how it's demodulated. Thanks for watching.